Hello and welcome to KT280 Tutorials. I'm your tutor Arnav, and today we are going to begin with the first chapter, which is known as crystal structures. In the first part, we are going to look at the introductory ideas and crystallography terminologies. First of all, solids are classified into two types, crystalline and amorphous. In crystalline solid, there are some repeated arrangement of molecules known as the bases, and these bases are repeated throughout the volume of the entire solid. Whereas in amorphous solid, there is no definite arrangement of molecules. You can see that the molecules will be arranged in any random order. You can see that from the name itself, morph means structure, and amorph means no structure, and hence we call this solid as amorphous solid. So let's talk about crystals now. The crystals, as we have seen earlier, have a group of atoms which is repeated throughout the space. That one particular group is known as bases, and space lattice will tell you how the patterns are repeated. It is basically a regular periodic 3D arrangement of points, and the basis forms one of the lattice point. The space lattice is also known as Bravais lattice because it was studied by Auguste Bravais. Now we have come to a very important concept called unit cell. It is the smallest volume which is repeated. Now this is a cesium chloride crystal. The chlorine atom is situated in the center of the unit cell, and cesium atom can be seen on the corners. Now the set of atoms which is repeated through the space is known as bases. But in unit cell, we are only concerned with this particular cubical volume. As you can see, only a part of cesium atom is present inside the unit cell. The part outside does not form a unit cell. I've shown this as whole just for simplicity. So this volume, which is a cube, gets repeated throughout the solid, and this is called unit cell. Now let us see what are lattice parameters. I have drawn here an outline of unit cell. Not necessarily it will always be cubic. As you can see here, the length of this side is denoted by letter A, the length of this side is B, and the length of this side is C. Also, these walls of unit cell need not be parallel. They can be inclined at different angles like alpha, beta and gamma as shown here. So these help in determining the shape of the unit cell, and these A, B, C combined with alpha, beta, gamma, the angles, are known as lattice parameters. So here we have summed up what we have seen in unit cell and lattice parameters. The most basic and smallest volume is the unit cell, which is repeated throughout the space, and lattice parameters are of two types. One is the basis vectors, which are A, B, C, and the angles alpha, beta and gamma. In case of cubic crystals, A, B and C are equal, and even angles are 90 degrees. So that's all for the introduction. We will get into more detail the next time. Till then, have a nice day.